Hello guys and welcome. I am Vishal Rati and I am a freelance software developer. Apart from being a software developer, I also train students in the subjects such as DSA, that is data structures and algorithms, and competitive programming. So without further ado, let's start with today's topic, that is tree traversals, right? So by now you must be knowing what is a tree, that is what is a tree data structure. So if you don't know, let me just do a quick recap for you guys. Tree is a data structure that is non-linear in nature, that is non-linear data structure. Data structure non-linear. What do I mean by non-linear? That is, it is hierarchical. It is hierarchical. Hierarchical means that there is a certain hierarchy that is maintained in this data structure. For example, you will be given a root node, that is, suppose this is a root node A. So this is your root node, and this root node must be having some children. For example, B, that is your left children of A, and then C, which is right children of A, right? So this is the hierarchical data structure, that it is not linear in nature. That is, you can't travel in the straight line always, right? You can't travel in the straight line always, right? Yani you have to, it means you have to traverse in some non-linear fashion. Okay, cool. So this is your tree, right? So tree is a non-linear data structure. Okay, so in this video we are going to discuss or talk about the traversals. So what do I mean by traversal? That is, we are going to traverse a tree. Now traverse means, that is, traverse a tree. That is, traverse means, in simple definition, it is nothing but just visiting all nodes of the trees or checking what value is stored. That is, checking what all values are stored inside the tree. Stored inside tree, right? So now the question may arise that, Vishal, why do we need traversal? Well, over the top of my head, for just simple basic CRUD operations, right? CRUD operations. CRUD means, that is, C for create, R for read, U for update, and D for delete, right? So for example, let me take a quick example. Again, let's say, suppose this is your node 1, this is your root node, and suppose it has a left children and whose value is 2, and it has a right children whose value is 3. Now 2 has a left children, a left child, sorry, for and its value is 4, and let's say 3 has a left child whose value is 5. Okay. Now suppose this is your tree. So this, so the question will be said to you that you are given a tree. That is, you are given a tree. So first of all, you must understand. First of all, you must understand that what do I mean by statement? Yeah, what do we mean by statement that you are given a tree? So it means, it just simply means that you will be given the reference. You will be given the reference of the root node only. Yes, this must be known to you that you will be given the access to the reference or access or the reference to the root node only, right? You will not be given the reference, direct reference to the node 2 or node 3, right? You will give given the reference of the root node only, and via this root node, you may access all of the descendants of this root node. Yes, so this is what we mean by that you are given a tree. So you will be given the reference to the root node. So if we are given the reference to the root node, suppose we want to, let's say, update some value. We want to update some value. That is, we want to do the U operation. Suppose we want to update this value of 5 to be 15. Suppose we want to update this, right? So in order to update this, what we must do is, we must start from this root node, and we must travel down to this node, right? We must travel down to this node, that is, traverse down to this node, and then only we can change this node. Yes or no? Yes. So that's the reason why do we need traversals, right? For basic CRUD operations, right? As simple as that, right? So this is the video where we are going to discuss about the traversal, different kinds of traversals. So let me just first of all write down all the traversals that are there, all the traversals that are there. So let me just quickly erase them and write down all the traversals are there. So approximately 10 traversals are there. So let me just quickly write them all down. So these all are the different traversals. So how many traversals are there? 10 traversals are there. So first of all, we have recursive traversals. That is, recursive traversals include in order recursive traversal, then pre-order recursive traversal, and then post-order recursive traversal. Now, what is in order? What is pre-order? What is post-order? This is just simply a fashion or a this is just simply a fashion of how we travel a tree, right? How we travel a tree. So this is the fashion of moving inside a tree, fashion of moving inside a tree, fashion of moving inside a tree, right? So what is this fashion? We are going to discuss these things in detail now, right? So in this video, for this point, for the purpose of this video only, we are going to discuss only these three traversals, that is recursive in-order traversal, recursive pre-order traversals, and recursive post-order traversals. Also, in the further upcoming videos, we are going to discuss about these traversals in detail as well. That is iterative in-order traversals, iterative pre-order traversals, and iterative post-order traversals. Similarly, there is another version for iterative traversals, which is iterative Morris traversal, which we also called as threaded binary tree traversal, in which there is also again in-order traversal, pre-order traversal, and post-order traversal. And lastly, we have level order traversal. Lastly, we have level order traversal. So if we talk about these traversals with perspective of graph theory, if you know graph theory, but by this time, I'm sure that many of you might not be familiar, many of you might not be familiar with the graph theory, but still there is something important that I want to highlight to you guys over here is that these above algorithm, that is the algorithms above this blue line, algorithms above these blue lines are simply called as depth first search traversals, and the algorithm that is below this line is called as breadth first search traversal. Now these are graph algorithms. So if someone asks you what kind of an algorithm in order traversal is, you might simply say that it is just simply a depth first search. DFS means depth first search, and BFS means breadth first search, right? So you might not be knowing what is DFS and BFS. Don't worry, we are going to cover these algorithms in detail in graph theory, right? But just to give you guys a hint, you must know these things now. Okay, right? Because when we are going to learn these things in graph theory, you might relate to these things such that you can relate to these things. Okay, cool. Now, since we are done with this, now let's talk about the that is first traversal that is we are going to discuss, that is in order recursive traversal. So let's talk about in order recursive traversals. In order recursive traversal. So first of all, let's understand what do we mean by in order. What do we mean by in order? So let's take an example of tree and then understand what is in order. So suppose this is your tree and we will take a very small tree for now. First of all, we are going to take a very small tree. So this is your tree 1, 2, and 3. And also you will be given the access to this root node only. You will be given the access to this root node. So when we say that we want to traverse in this tree in fashion of in order, that is we are going to traverse in this tree in order fashion, then we say, okay, in order means ki, hey, we are going to first travel the left child. We are going to travel towards the left child. That is, we are going to first visit the left child. Then visit root node, and then visit right child. So in short form, if I write it down as such, that is left, root, and right. This is the shorter form. So for this simple tree, if we write down in order traversal, the in order traversal must look like 2, 1, and 3, because 2 is the left child, and then we have the root node itself and the right child, right? So this is that is in order traversal, right? So now let's take it to another level, that is next level. So let's update this tree. Now let's take a bigger tree. And see how this will work for a bigger tree. So suppose this is now 4, this is now 5, and now this is now 6, and now this is now, let's say, 7, right? So suppose this is your tree, right? So we are given the access to the root node only, right? So now we can erase all of these things, right? We can erase all of these things, and we must just remember only this portion, that is in order traversal means that is left, root, and right. So earlier I used the term that is left child. So instead of left child, it in general sense, generally means left subtree, then root value, and right means right subtree. So the general definition is this. Okay. So this is root. So first we are going to visit all the nodes inside the left subtree. So in order traversal states, hey, before visiting the root node, visit all the nodes in the left subtree. Visit all the nodes in the left subtree. Okay, cool, makes sense. So we are going to do is we are going to visit all the nodes in the left subtree. Right? Now, since we are going to dry run this, so what we are going to do is we are going to write down the code hand by hand as well, right? We are going to write down the code together, right? While we do dry run, um, so while we do dry run, parallelly we are going to write down the recursive code for this. So this is going to be a recursive algorithm. So we are going to write down a recursive function for this. So I am going to name that function as in order recursive, in order and recursive. So this is the name of our function. And now, so what will be given to us? So we will be given a tree, and we will have to travel the tree in order fashion. So what argument should this function take? It should just take the root node as argument, Yes, that is the tree. So root node, what is the type of root node? That is, what is the data type? I can say something like node star. Now node star, right? So you must be knowing how do we create a tree, right? So that is how we create a tree. Simply a node will be given to you. Node either can be a struct or can be a class. It will have a member of, suppose, let's say, int val, and then node star left, and another member of node star right. So this is going to be your structure of this node, right? So if I say root dot left, it means the left subtree of that root node. And if I say root dot right, it means the right subtree of the root node, right? So you must be given this root node, right? So I'm erasing this root node, is this node structure. So this is what is given to you, right? This is what is given to you. Now, this is going to be a recursive function which prints the in order traversal. So in order to complete any recursive function, we what we do is we say, hey, just first write down the function name, its arguments, and its return type. Now, since it is just printing, what should be the return type of this function? Can I say it should be void? Yes, because we are just printing all the values. Yes, so the return type is void. So after writing down the return type, after writing down the name of the function, after writing down the arguments it is going to take, we are going to assume that this function is complete in nature. We have not written anything inside the body, but just to complete the recursive function, what do? We say, hey, this function is now complete. And complete in the sense that the definition that we are going to provide to this function is now complete in nature. So what is the definition we are going to provide to this function is, I'm going to say, hey, this function takes root node as an argument, that is, it takes a tree as an argument, and prints in order traversal, prints its in order traversal. Okay. So I'm assuming that the definition that we have given to this function is that this function will completely follow the definition, and it will completely fulfill that definition. We have not written anything. So that's the magic of recursion you are going to see in a moment, right? Okay, so we say, hey, that is, now we have created a function, right? Now we are going to see how dry run will look like, and from the dry run we are going to write down the code. From then we are going to write down the code. Okay, so we are going to start from the root. So root will say, hey, first print the in order traversal. First print the in order traversal of the left subtree. So one will say, hey, first print the in order traversal of 2, right? So we are going to visit 2. Okay, cool. So 2 is another tree on its own. 2 is another tree on its own. So 2 will say 2 will be acting as a root node on its own. 2 will be acting as a root node on its own. It will also have left child and it will also have right child. Yes, makes sense. Yes. So 2 will also say, hey, first print the in order traversal of my left child. So 2 will call, that is, first you should print the in order traversal of 4. Yes, makes sense. Yes. So 4 will say, hey, I'm also a root node on my own. So what I'm going to do, I'm also going to call my left subtree. So what is the left subtree? It is going to be null. It is going to be null. And also right subtree, it is also going to be null. Similarly, for 5, left subtree is going to be null. Right subtree is also going to be null. For 6, left subtree is going to be null. For 7, left subtree is going to be null. For right subtree also going to be null. For 3, right subtree is going to be null. Right? So now we have written all the null values as well. So 4 will say, hey, for this null, print the in order traversal. The root is null. The root is null. So tree will say that is, it is an empty tree. So this will also behave as a root node, and this root node is empty. That is, this is an empty tree. So it will say, hey, I don't have any in order traversal because I'm an empty tree. Okay, so it will say that is, it did not print anything. It did not print anything, and it went back to 4. It went back to 4. And 4 said, okay, my left tree has been processed. My left tree, my left child, my left subtree has been processed. Now it is time for me to get processed. Now it is time for me to get processed. So what we'll do is, it will print 4. So output here is going to be, the first output that we are going to get is 4. Okay, cool. So 4 is printed. So 4 goes back to 2. 4 now goes back to 2. So this now returns, and 4 goes back to 2. So 2 says, hey, my left subtree is done. My left subtree is done. So what is the next thing that I should do? I should print the root value. What is the root value? 2 only. So the next value that is going to be printed is 2. Okay. So the root is printed. What is the next value that should be printed is the right subtree. Is the right subtree. Okay. So the next thing that is 2 is going to call is 5. Hey, print the in order traversal of this tree, So 5 will act as a root node on its own once again, and 5 will say, hey, do the in order traversal of my left subtree first, right? So left subtree is null for 5. Left subtree is null for 5, right? So left subtree of 5 will say, hey, I don't have any in order traversal, so just return back. Then 5 will say, okay, hey, my left subtree is done because it is null. So what should I do? I should do, that is, I should print root value. What is root for 5? Only 5. So 5 will get printed. 5 will get printed, and similarly 5 will call for what? That is right. 5 will call for right subtree. Okay, so right subtree is also null. Right subtree is also null. So for 5, left, root, and right are both done. So it will return back. And say to 2 that, hey, 2, your right subtree is also done. So since all the left subtree, right subtree, and root, all these three things have been processed for 2. 2 will say, hey, I am processed. I am fully processed. So 2 will say to 1 that, hey, 1, your left subtree has been processed. Yes, your left subtree has been processed. So 1 will say, if my left subtree has been processed, what is the next step for me? That I should print my root value. That is, what is the root for 1? The root for 1 is 1 itself. Yes. So the next value is going to be 1. So after printing 1, what should 1 do? It should call for right subtree in order. Right subtree in order means, that is, for 3's in order. So 3 will say, okay, I am a root node now. I also have a left child. So it will say, hey, 1 is going to call 3. 3 is going to say 6. Print your in order traversal first. So 6 is going to print its in order traversal. So 6 will now again act as a root node on its own. 6 will say, hey, first, why don't we do the in order traversal of my left subtree? So we see that 6 does not have any left subtree because its value is null. So left subtree will say, hey, I don't have any in order traversal. So you just return back. So the left subtree traversal return backs, and what do we do? What do we do next? That we print the root node value. What is the root node value? It is 6. It is 6. Okay, 6 is now processed. 6 is now processed. Okay, cool. Now 6 says, hey, for me, left subtree is processed. For me, root is processed. That is 6. What is left? Right subtree. Right subtree. So 6 will say, now print the in order traversal of, now print the in order traversal of 7. Now print the in order traversal of 7. Right? So 7 will say, hey, I'm a root node on my own. I'm a root node on my own. So for first I should call for my left subtree, but there is no left subtree. So left subtree should just return. So it returns. And then what should the next value 7 do is, that is print 7, because 7 is the root node. Right? So 6 and यहाँ पे that is here 7. Okay, cool. Now for 7, this is done, this is done. What is left is right subtree. So right subtree is also null, so it just also returns back. Now 7 returns back to 6. 7 returns back to 6. Says, hey 6, your right subtree is done. So 6 says, hey, my left subtree is done, my root is done, that is 6 is done, and my right subtree is done. So I can think and say, yes, I am done. I am done. So 6 will answer to 3, yes, I am done. That is my in order traversal is done. So 3 will say, hey, if 6 in order traversal is done, 6 is in order traversal is done, then I must say that is, this is done. I must do this. I must do this. So 3 will say print root. And what is root? 3. Right? What is root? 3. And then what is the next step? Print right in order traversal. So it will go to right and encounter a null, encounter a null. So it will be an empty tree and it will return back and it will say, hey, your right in order traversal is done. So 3 will say, okay, my left in order traversal is done, my right in order traversal is done, and my root traversal is also done. That is, I have printed root as well. So I should just say return back and say to 1, hey 1, your right traversal is done, your right traversal is done. So 1 will say, okay, 1 will say my left subtree is done, my left subtree is done, my root node is done, and my right subtree is done. Then I can say that I am done. Yes, I am done. So 1 will say, hey, the in order traversal is complete. And what is the output of in order traversal is 4, 2, 5, 1, 6, 7, 3. So in a way, I can say that is, first you should go to the left, 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 and then when you encounter a null, you come back. You come back and then print the root value, then move towards the right, and then again move towards left, 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 left. Right? So this is the thought process. So if I give you some sample trees, for example, 1, 2, 3, right? So I am giving you just a sample 3. You must write down its in order traversal, right? So this is a sample tree. You must write down its in order traversal, right? So pause this video right here and write down its in order traversal. So for those who have written down their in order traversal, what should we do? That we should first travel from the root node towards left, 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 and counter tunnel, come back, that is 4. Then move towards right, right, then also again left. So left and then left. Left is null. So encountered null, come back, that is 6. So should print 6. And then where? Then move towards the 6 is right. Move towards this 6 is right. Okay. 6 is right is null. It is also done. Then it comes back. So it comes back. So what should we do? We came back to the root node. So output should be 5. Then after 5, the right child of 5, that is null. So it is also done. Then it says I'm also done. So 4 left is done, 4 left is done, 4 left is done, 4 itself is done, 4 right is done, then 4 returns. 4 returns. So we should print this value, that is 2. Then now call for 2's right. There is no 2's right, so it should return. It returns, so we should print 1. Then now call for 1's right. 1's right. Okay, cool. 1's right is done. Now 1's right, we reach. 1's right we reach. And then after reaching 1's right, it call for left. There is no left. There is no left. That is null. It left comes back and we should print 3. So we should print 3. Then it should call for right. Then right, for this we should also go to the left. So we go to the left and that is 8. And then it also it also does not have any left, so it will just come back and print 8, and then we'll move to right. Doesn't have any right, then it also comes back, and then we print 7. Then we print 7 and moves towards the right. there is no right. So we come back. So we come back from here, right? We say, hey, right is also done. And then we come back from here, say, right is also done. And then we come back from here, say, hey, right is also done. So this is the output, 465 to 1387, right? 465 to 1387. So in a way, can I say, in order traversal of any tree, in order traversal of any trees, hey, first do the left subtree in order traversal. That is, first do the in order traversal of left subtree. Then print the root value, and then do the in order traversal of the right subtree. Yes or no? Yes or no? Right? So now we have to convert this into piece of code, right? So this is our observations, this is our dry run. So how do we convert this into piece of code? So what is the first step? What is the first step? Well, we want to do in order traversal of root's left child. We want to do in order traversal of root left child. Now, what is the function? What is the function that does so? Well, we just created a function. Right? And by the definition of this function, it will print any trees in order traversal. It will print any trees in order traversal. So it is capable of printing what? Roots left in order traversal. So can I say, just simply do call in order recursive, and with what? With what? Node, not node, simply root dot left. Yes or no? Yes. And then after doing this, what should we do? We should print what? Root dot val. And after printing root dot val, what should we do? In order traversal for right subtree. Yes. So can I say that is in order recursive root dot right? Yes. So this is your, that is recursive traversal, and these are your recursive cases. Recursive cases. Yes or no? Yes, exactly. So these recursive cases are done. But recursive function has two things to fulfill. First of all is recursive case, and then second of all is base case. Yes. And now we know the concept of recursion, that if you know the recursive case, just follow this recursive case, and you will definitely reach at some point the base case. You will definitely reach at some point the base case. So if we say, hey, in just short, we are saying from left, from root, we are just going to travel left. We are just going to travel left. So we travel left, we travel left, we travel left. We encounter a null. We encounter a null. So this function takes in the third step, a null. For this tree, that function takes in the third step a null value. So what will this function expect? That the root that is provided here is null, and it should print its in order traversal, but the root is null, so it will have no in order traversal. Yes. So can I say the base case will be that is simply if root is equals to null. In that case, what should we do? We just simply say, hey, return. You don't have any in order traversal. Yes. So now this is your function is complete. This your function is now complete. Right? Now let's do a quick final dry run for this. Step by step, using call stack and recursive tree. So what I would like you to do is just remember all these 4 lines of code. These 4 lines of code are easy. Yeah, right? Easy peasy. So let's do a final dry run. So we are going to take a small example, that is, this is your 1, this is your 2, this is your 3, and this is your 4, and this is your 5. And now we are going to draw the null values. Ye null, this is 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 null. Okay, cool. So you will be giving the reference to the root as 1. Okay. So first of all, what is the first goal? What is the first call that is going to happen? Right? So in order recursive for 1 is going to happen, right? So I am going to say, hey, the first call will be, suppose now I am denoting this function name as with R, right? Or IR. Let's say suppose IR, the initials, right? So IR. So I am going to say the first call is going to be IR of root. And what is the value of root? 1. Since all the nodes are distinct, I can denote this root node by the value inside them, So this is the first call. This is the first call. So what is going to happen in this first call? So let us just draw the call stack as well. Let us just draw the call stack as well. So this is going to be your call stack. And here we are going to track the recursion. Here we are going to track the recursion. Okay, so this is your call stack. So the first call that is going to be inside this is IR of 1, IR of 1. And somewhere here, that is we are going to track the output. Somewhere here we are going to track the output. Right? So I'm going to write output over here. Right? So the first call is going to be IR1. So what is the first statement in any function? That is in this function, that is in any call of this function, the first statement should be if root is equals to null. So we will ask, is 1 null? No, 1 is not null. 1 is not null. So what do we do? Hey, in order recursive of root dot left. So it should call what? It should call, that is this value, that is this guy, that is, it should call IR of 1 dot left. What is left of 1? That is 2. Right? So this function call should go inside the call stack, that is IR of 2. Yes, it is gone. So now what will happen is the topmost call in the call stack, must execute first, must execute and complete first. Then only we will continue with the call stack, that is call lower than the top call in the call stack. Yes, right? So first IR2 will be completed. So go inside the IR2, that is function of IR2. So for this function as well, what is the first statement that we are going to check? Hey, is 2 null? Is 2 null? We say no, 2 is not null. So this condition is false. So what do we say? Hey, in order of root dot left. Now what is root for this function? Can I say the root for this function is 2? Yes, the root for this function is 2, right? 2, because we are passing 2 as argument. So what it will say? Hey, do the in order recursive of 2 left, 2's left, which is 4, 2's left, which is 4. So now IR of 4 must go inside call stack. Yes, right. Okay. Now similarly for this, we will ask ourselves, is 4 null? No, 4 is not null. So you say, hey, do one thing. What? All the IR left. Now what is the left? 4's left. It is null. 4's left. It is null. So the call stack is going to call IR of null. IR of null. So it is going to say, hey, is root null? Yes, it is null. So you say, hey, just return. Hey, just return. So it will say, hey, you just return. Hey, you just return. You just return means take this call out of call stack. Take this call out of call stack. Okay, good. So come back to IR of 4. So for IR of 4, this call is done. Yes, this call is done. Yes. What is left is print root dot val. So what is the value of root for IR of 4? We say 4 only. So 4 is printed. Then what is the next step? What is the next step? That is in order of root dot write. Root dot write. Okay, cool. Call IR of force write. Force write is nothing. Again null. So again IR of null is called. IR of null is called. Yes. So it says, hey, is root. What is the root for this? Null. Null. So you say, hey, is root null? Yes, root is null. So you just say, hey, return. Hey, return. It means take this call out of call stack. Yes, done. Okay, done. So here, so this function returns. So IR4 says, hey, my left is done, my this is done, and this also returned. This also came back. So can I say that is IR of 4 is done? IR of 4 is done. Yes, I can. So IR of 4 says, hey, I'm also done. So I must return back. So IR of 4 goes out. IR of 4 goes out. So IR of 4 goes out. Right? IR of 4 goes out. Now, as soon as it comes out of the call stack, we resume with the IR of 2. So in IR of 2, this was done. That is IR of 2's left call is done. IR of 2's left call is done. What is left is, that is print root and write. So what is root for IR of 2? What is root for IR of 2? That is, it is 2 only. So 2 is printed. Then what should we do next? It is write. IR of write. So what is IR of 2's write? That is IR of null only. So IR of null goes into call stack. Right? So now we will do a little faster. Yes. So it is null. So it comes back. So it comes back. Right? And Now this also goes out to the call stack and say, hey, my left is done, my root is done, my right is done. I should return back. I just simply should return back. IR of 1 says, hey, my left is done. What is the next value? That is print root's value. What is root for IR of 1? 1 only. So 1 is printed. And now what is the next step that we should do is, we should say, hey, IR of 1's right. What is 1's right? That is IR of 3. So also, we missed one step over here. That is when 2 came back, 2 also came out. 2 also came out, right? So in all stack, 2 must also come out. Sorry, my bad about that. So 2 also came out. Now IR of 3. So IR of 3 will be inside the whole stack, right? So IR of 3 will say, hey, that is first step is do my left. That is IR of 3's left. What is 3's left? Null. So IR of null will go inside whole stack. IR of null goes inside whole stack. So root is null. Yes. So this comes out, and comes out, right? This comes out. So we are just going to use white only. This comes out. So this comes out out of whole stack. So IR of 3 says, hey, my left is done. What is the next value? Print root. So print root, that is 3. What is the next step? That is go for right. That is IR's right. That is 3's right is 5. So IR of 5 is called. So 5 says, do my left first. IR of null. IR of null. Null says, hey, I am null. So just return back. Just return back. So this is now taken out. Now, as soon as it runs, IR of 5 says, hey, my left is done. What should I do next? I should print myself. Yes. And then call for IR of right of 5. Right of 5 is null only. So again, IR of null goes, comes back, right? And then IR of 5 says, hey, my left is done, myself is done, my right is done. I should go back, I should go back, I should go back. If I go back, I should come out of whole stack. Okay, cool. IR of 3 says, hey, my left is done, myself is done, my right is done. I should also go back. Go back means take out of the whole stack. So IR of 3 says it is done. So IR of 1 continues. So IR of 1 says, hey, my left is done, myself is done, my right is done. So I should also come back. So it also comes out. So this is your final in-order traversals 42135. Yes. So this is your final traversal. Now, what if we talk about the time complexity and space complexity of this function? So time complexity, can I say for each node, there are going to be that is for each node there is going to be exactly one pole. There is going to be exactly one pole. So for example, if n nodes are there, then time complexity is nothing but big of n only. Yes, big of n only. Yes, can I say that? Yes. So time complexity is big of n only. Okay. Now what about space complexity? Can I say space complexity of this recursive function will be only the call stack space that we are going to use, only the call stack space that we are going to use, right? Does it make sense? Yes. So the call stack space for recursive function is, if we go by the definition is, that is the maximum number of function calls present at any given moment is the stack space. So what are the maximum number of calls that were present? So can I say, first of all, IR1 was there, then IR2 was there, then IR3 was there, IR4, sorry, IR4, then IR of null, right? So at most 4 nodes were there. At most 4 nodes were there. So space complexity is, that is big of 4, right? And what is 4? What is 4? Nothing but just simply this height, this height. So can I say, in the worst case, how many function calls are going to be inside the call stack at any given moment? At any given moment. So can I say that is only the height of the tree? Yes, only the height of the tree. So the space complexity is nothing but big O of h, height of the tree. Now, h can be big O of n in worst case, when there is a skewed tree. For example, a tree is like this, right? A tree is like this. So in that case, that is height of the tree is nothing but the total number of nodes. So in that case, the space complexity is going to be big of n, So this was our, that is in-order recursive traversal. So similarly, now you have understood this. Understanding pre-order recursive traversal is fairly simple. Pre-order recursive traversal is fairly simple. We just have to understand what is the definition of pre-order. Pre-order means, that is, hey, first we are going to print root value, Then we are going to print the left value, that is left subtree is pre-order, and then right subtrees pre-order, right? And similarly for the post order as well. So that is we are all going to discuss in this video. So this is, I think, good enough for a short video.